All right, so we've got ourselves a radical problem here. We're being asked to simplify completely, but if we look at what's going on here, this is an addition problem. And when it comes to addition, remember that the basic idea is combine like terms. We don't have like terms that are obvious yet, but again, you remember that when you dealt with these problems earlier in the semester, you had to simplify each radical first. Once you simplify them, then yes, maybe they were like terms, maybe you could add them together. So this problem's probably going to take us a little bit to get through the full video because I want to talk about a lot of stuff that's going on in this problem. The first thing I want to talk about is being a smart student test taker, looking at the multiple choice options, looking to see which of them are reasonable. With this particular problem and this particular set of multiple choice options, you can actually probably get down to the right answer without doing any real work at all. So, as I look at the multiple choice options, option A, I can cross off without even looking at the original problem. And I can cross off A as an answer that would not be a reasonable answer to any question ever because of the fact that we've got this A cubed underneath a square root. What that tells me is that this could be simplified further, so it's not a final answer. Now, the interesting thing in this particular problem is that that is equivalent to the correct answer, which is something you got to be really careful about in a multiple choice test like this, because on a normal test that's handwritten, if you give me an answer that's equivalent to the correct answer, there's a good chance you're going to get some partial credit. On a multiple choice final, goose egg. You're getting 0 points for an incorrect answer. So you got to be really careful about that. Now, as I look at option B, let's go back to the original problem for a second. We said the basic idea in this problem is to simplify each of those radicals separately. So break it up, take the radical, clean it up, and then combine like terms. So as you look at the radicals we have in the original problem, neither of those radicals are perfect squares, meaning we're still going to have some radical stuff left over in the end because it's not just all going to go away because of it being a perfect square. Which means B can't be the right answer because B is telling us they all go away. All the radicals go away in this problem, and they don't. They quite clearly don't. So B can't be the right answer. Now, as we're left looking at the difference between C and D, you've never seen an answer as complicated as D anywhere in your normal work. So I'm not going to give it to you on the final. We're not going to end up with some coefficient that needs to be factored because there's some common factor in there. That's just crazy. So that particular one we can probably throw out and probably get an answer as C fairly quickly. Now, that's a little fuzzy reasoning there at the end. The A and B definitely cross off. The D, that's a little fuzzy. So let's talk about another approach. Now, I'm going to talk about two other approaches here. We're going to talk about the actual normal correct approach to this in a minute. But before we get to that, I want to talk about what if you're completely stuck? You have no idea, you don't remember how to solve these problems at all. I want to take a step back and go all the way back to the first video I assigned. The very first video I assigned had a section in it where we looked at the difference between equations and expressions. And those are the two big categories that pretty much everything we deal with in all of algebra can be broken down into one of those two situations or a slight variation on those two situations. An equation, which is not what's going on here, an equation has an equal sign in it. Generally, what you're looking at with an equation is trying to solve an equation, find a solution. A solution to an equation is a value or values for the variable or variables that make the equation true. Now, in a multiple choice test, we can oftentimes, with an equation, just take the answers and plug them back in and see which of these make the equation true. Now, with an expression, it's not quite as simple, but we can take a similar approach. The idea with an expression, which again is something that does not have an equal sign in it, the idea of an expression is to start with an expression and end with an expression that's equivalent to the original expression for every value in the domain of the problem, meaning any value for variables that I could plug in at all, I should get the same answer if I plug it into the original as I do if I plug into the answer that I give. Those two expressions should be equivalent. So if C is the correct answer, then any value for A and B that I plug in to 39a squared b square root 5a should give me the same number as if I plug that same a and b into the original problem. That's the idea. So if you're completely stuck on a problem, what you could do is just pick a number for a and b. I'm going to pick 3 for a and 7 for b. Now I picked those two numbers because they're both prime numbers. That's important. I want to pick prime numbers that are a little bigger than your ones and twos that you might think about, or zeros. So we don't want to plug in 0, 1, or 2 because then you're going to get things that are equivalent by accident. And we don't want to see that happen. Because here's something I want to stress before I show this example here. I really want to stress, this is important, that what I'm about to show you is only a method for process of elimination. We're not going to prove that an answer is true. What we are going to prove is if an answer is wrong. That's all we can prove. So that, for instance, if I said x plus y equals 2x, that's not a true statement. But what if I plugged 2 in for both x and y? Then it would become a true statement all of a sudden. So you can accidentally get things that are true, even though in general they're not. So, as I plug 3 and 7 in here, we're going to plug 3 and 7 into the original problem first. And let me get my calculator out to show you a good, efficient way of doing this. What I'm going to do is I'm going to store 3 as a. So I hit 3, I hit the store button, which is right above on, and then I hit my variable button until I saw an a and hit enter. I'm going to do the same thing for 7. I'm going to say store 7 into b. And now all I'm going to do is type the original problem. Now, in the interest of time, I've actually already typed out the original problem. So I'm just going to hit enter on it again, and I get this number 9515. I'm going to jot this down over here. 9515 followed by some decimals. So now if I do the same thing for option A, which again I did pre-type this just to save time in the video. So if I have 39ab square root 5a cubed, I actually get the same value. So what that tells me is I actually can't cross off that value because it could be equivalent. It doesn't mean it's the right answer, and it's not. Remember, we said that that's not simplified. Now if I go to the other 1890 value, then I get some crazy 2 something. So how many? That's what, 22,504,000. That's when we can say that is not the right answer because it doesn't match up. Now, let's just go ahead and peek back up at these other ones that I already pre-did. We can see that the 39a squared, the c, is equivalent, but this d is not equivalent. So this is where we get the answer of c does work since a is the unsimplified version of it. So again, that was not efficient. I want to stress that method I showed there is not an efficient way of solving problems. It's just a method you can use if you're completely stuck. Now, if we actually wanted to solve this problem as a refresher, we're going to start off with break it up, take the radical, clean it up. So 20 is 4 times 5. A cubed is a squared times a. And b squared is already a perfect square. Then we have 7b. 45 would be 9 times 5. A to the 5th would be a to the 4th times a. Now, one thing I'd be careful of on problems like this, and I'm definitely guilty of it, is making sure that your a's are different from your 9's, so you don't make a handwriting mistake that throws you off. So now that's the break it up step. Remember what I've said earlier in the class too, is don't try to combine steps. That's when errors happen. The next step is just take the radical. Any of our perfect squares will take. So the square root of 4 is 2. The square root of a squared is a. The square root of b squared is b. The other ones just copy down. And this is why we work vertically, so we can make sure we've accounted for each thing. The 7b copies down, and now let's just take the square roots that we can. Square root of 9 is 3. Square root of a to the 4th is a squared. We're careful that when we take a square root, that the square root symbol is no longer there. Then we just copy down the radicals that we couldn't simplify. Now we clean it up. So now we take a look at this guy over here and say, I have 9 times 2 outside the radical. That's 18. I have a times a outside the radical. That's a squared. And I have a b outside the radical. That's b. Inside the radical, I have a 5 and an a. Then I take a look at the second term. Outside the radical, I have a 7 times 3. That's 21. I have an a squared. I have a b. Inside the radical, I have a 5 and an a. And now I do, in fact, have like terms because both of these are a squared b root 5a. So if I just add 18 and 21 together, I get 39. And then I just keep the same term. And we get this answer of C by simplifying, doing the break it up